So, again, a step away from systems.
Yay.
The algebra of matrices. Let's just come up with a few matrices. And these are my favorite things to make up because I'm so creative.
Oh, sure.
Negative
What are you
1.
laughing about back there?
That funny joke. So we just make these just randomly, just out the blue?
I'm just making these up for
Why didn't you go to 6 instead of
Yeah.
But you did not.
just to throw you off.
But why would you do? Why? That's so mean.
Can we make it a 6? Well, then the problem would be
All right. So I'm just making up 4 random matrices. Now, a matrix is literally just an array of numbers, okay?
Got it.
That's all. We've already been dealing with them, showing the array of those coefficients of the systems, right? But a matrix actually has a size. And the size is the number of rows by the number of, what do you think? Columns.
So it's the area.
No, you don't multiply them. Literally, if I tell you to give me the size of matrix A, 2 by 2 by 2. Matrix B, 1, 2, 3 rows, 2 columns, 3 by 2. What about this one though?
That's nice little rows.
2 by 3.
2 by 3. This one is another 2 by 2. I mean, we could even go E is 1, negative 3. What size is that one?
2 by 1.
2 by 1.
Row and a column.
The number,
Columns are like building.
rows go this way, right? Columns go vertically.
Then why would it be like
2 rows, 1 column. 1, 2, 3 rows, 1, 2 columns.
That's weird.
I'm following.
Think of like a.
It is just a retraining. It's a retraining your brain. So, we have this thing called scalar multiplication, which is super easy. If I tell you to give me a representation of what 3a is,
How do you spell scalar?
It's right there.
L-A-R.
Yes, but I can't. Yeah. Is it A-R?
Scholin?
It's A-R,
Scholar?
scalar, scalar.
Scalar.
All right. Scalar multiplication is essentially the distributive property.
Oh, yay.
I'm going to scale every single term of A by 3. So what is it? 3 times 1 is 3. 3 times 2 is 6, 9, and 12.
She wanted 3. Oh.
It's an example.
That's how, okay.
These are just examples. Now, addition and subtraction. The only way we can add or subtract matrices is if they have the same size, right? Only if they have the same size. Kind of. Like,
Are you saying you could add one matrix by the other?
yeah. So like, could I add matrix A plus matrix B?
No, you could add it
No,
by
not
D.
possible.
A and T.
So I can, here, let's be creative. Let's say 2A plus D. 2A is 2, 4, 6, 8. That will be the same size, right? 1, negative 3, negative 2, negative 5. So literally I'm just writing out, this one is 2A, this one is D, and term by term, we add them. That's how you add matrices. It's the easiest thing. 2 plus 1 is 4 plus negative 3, 1, 4. Everybody following that? It is that easy. If I had subtraction, how about let's go D minus A?
Yeah, I was waiting for it.
Do what?
What's the catch?
There's not a catch on the matrix operations for real.
Okay, so what is there catch on?
Multiplication.
Not surprised.
And guys, you know me. I show my Algebra 1 middle school step of distributing the negative. I just do. That way, because I can look at them term by term, it's easier. 0, negative 5, negative 5, negative 9. Everybody with me on that one?
-9, why wouldn't it be 4?
Negative 5 plus negative 4 is a negative 9.
It was 1, 2, 3, 4 in sheet.
The original one was 1, negative 3, negative 2, negative 5 for D. This is D
I wrote down negative 4 and stuff.
plus negative A.
Oh yeah, it's D in the original was the 5 was
The 5 is
positive.
positive, it's 1.
That's why I'm confused. No, in the D. In
All
the
right, one more
first
time, term by term.
The D.
The D, the
In the D
original
one.
D is
Was
5.
negative 5.
It's
The original D was negative 5. I did not change it.
mine says 4. Mine says 4.
Sorry, I had it written down wrong, that's why I was confused.
So we're okay now?
Yes.
All right.
And I explained
Yes,
it
I
out.
mean, if you don't distribute the negative, 1 minus 1 is 0. Negative 3 minus 2 is negative 5. Negative 2 minus a negative 3 is also negative 5. Negative 5 minus 4 is a negative 9.
Minus D.
Oh, I got you. So, any of the other ones, really, we could not add or subtract them. They have to be the same size. Feel good about it?
Yes.
Can there
All
be a
right.
matrix that's a
matrix?
matrix that's 1 by 1?
I mean, yeah,
Or
but
would that
that's
just be
just,
adding numbers?
that really is just a scalar itself, right? All right.
Just multiplying and adding.
So there's one type of equation they tell you to solve. Like, if I say solve for x, 2a minus 2x equals d. Ooh.
So do we just fill in the 2A?
2a would be the 2, 4, 6, 8, right?
Or didn't you just, like, minus, like before you even write down, just put minus the 2A and put it with the D? And then it just
Oh,
minus 2A.
so you're saying,
Before you even.
or even maybe 2a minus d equals 2x?
Yeah, because then it's right.
Ooh, and then what do I do to actually solve for x? I like it. I like it better.
What were you gonna show us?
I was going to show you and do stuff term by term, and it will eventually be term by term, but what is 2a minus d?
That. We have it.
2 minus 1 would be 1.
Oh.
I'm
It's,
just like,
1, 7, 4, 13.
4 minus a negative 3 is 7. 6 minus a negative 2, you get 8 here. 8 minus a negative 5, you got 13.
I
He didn't get 8.
didn't get 8.
6 minus a negative 2,
Oh, I forgot to turn that into a not negative.
There you go.
That would do it.
That would do it.
Equals
Those are
2x.
negatives.
Can you
I got
divide
a 4.
everything by 2?
multiply by 1/2, make it a scalar, yep. And x will be ugly because I made it up off my top of my head, but that's okay. What's 1/2 of 1?
1.
Half. Half of 7. 7 halves, half of 8, 4, 13 halves, done. I like it. So literally, we can solve it kind of like a literal equation and then do the matrix operations. I like it.
What were you?
Why are we just now learning this? Like, why did we not learn this? This feels so simple. I feel like.
It feels like
It is pretty
it should be
simple.
algebra we just did it.
Yeah, it feels like we should, after everything we've done in this class, it feels simple. I feel like we should learn.
To move on to matrix multiplication.
I like structure. You make everything sound so fun.
Still in 10.4, we're still doing operations. We did addition, subtraction, scalar multiplication.
Like structure
Yeah,
will be
still,
like, okay,
still 10.4.
so we're gonna watch Finding Nemo in German,
So-
and then you're gonna get a worksheet, and that's the funnest part about what he's saying. I was saying how she made it.
All right,
made it.
matrix multiplication only works if the number of columns in the first matrix
No thing.
equals the number of rows
Whoa.
in the second one. Then only works if the number of rows in the first matrix equals the number of columns in the first matrix equals the number of rows in the second.
So if it's like 8 by 2, the other one has to be something, or something by 8.
No, the two rows by any number of columns. So A was 1, 2, 3, 4. B was 1, 2, 3, 4, 5, -1. What was C? 1, -2.
2, 3, -4, -5, 6.
Okay. That's gonna be enough to start. Well, give me E. What was E?
1, -3.
B times A?
All right. So, what's the size of A? Let's list the sizes.
2 by 2.
2.
3 by 2 is B.
Just hang on,
We have matching pencils.
except for mine. The lead is out. It was probably the lead you. All right.
Parental rule.
So, list out the sizes. 2 by 2, you said? 3 by 2.
Yep.
So, can we say A times B? A 2 by 2 times a 3 by 2. The number of columns in the first one must equal the number of rows in the second one. Our answer is not possible.
This is gonna take me a minute.
Rows by columns,
So if you get
Times-
columns, C and D. Columns and
rows by columns.
so if you set them up next to each other.
I set them up next to each other and I look, do they match? Not possible. But is B times A possible? A 3 by 2?
Because every other time it means the same thing.
So guess what we know about matrix multiplication?
It's stupid.
Matrix multiplication is not commutative. The commutative property does not apply.
That's the catch. But not
That is a catch.
So when they told me commutative property,
Rely on that property.
it's applicable to everything except for the matrix multiplication.
And probably something else that we just don't know. Apply.
We can't see what you're writing, by the way.
I'm just writing them side by side. Now, guess what size the answer matrix is going to be?
It's 3 by 4.
3 by
4 by 3. 9.
3 by
3.
3.
Whoa.
That is what the answer matrix is going to be. And here's what I usually do.
Why did you this whole thing?
And so,
Where'd you get the 6
second three.
So
Where'd you get the
those
second
numbers
three?
need to be the same so that the
should be
outside.
Oh, it's 2 by 2 by, I'm so sorry. I wrote it down wrong. So it is a 3 by 2. Good call.
You're
Sorry.
welcome.
Hold on. Why do you do 3 times 3?
I had written that wrong.
No, but
You ignore the middle one and you use the outer ones.
Show me, must be.
So you have to use the middle ones to see if they match, and then use the outside ones
Is the answer. That's how you write the answer.
Yeah, so here's what I do when I start my matrix multiplication. I know what the answer size is gonna be, so I write down my blanks. This is where you have to have a little bit of coordination, and because a lot of you are in band, you're going to have this coordination. I know you are.
I doubt it. I'm not in marching band.
It don't matter. You still have some musical background. So, with your left hand, you think,
Oh, okay.
I'm gonna go across. I'm gonna start here, I'm gonna go there, then I'm gonna go down here, and then go to the 4. Then I'm gonna go down here and go to the -1.
So you go
With your left hand, you start at the left and go to the right, only rows. With my right hand, you start at the top and you're going to go down.
Wait, oh my gosh.
So every practice in the air. Left hand goes across, right hand goes down. Move,
What?
Practice.
It's like the.
left hand goes right, right hand goes down. Let me see. Everybody do it in the air.
left hand goes right, right hand goes down. So
At the same time.
Wait, so
I need to do it.
so
I
you
need.
go like
Pardon,
this and
please.
then you
Got
go
it.
diagonally?
Got it?
what do you do once you go down?
Down.
Yeah, what do you do
There
when
you
you
go.
got it? You run out.
Right, you run out. So here we go. We know our answers are 3 by 3.
That's
I'm
why they
starting
use
at
the
the,
same number.
are you listening?
Yes.
Starting at the top left for both of them. 1 times 1 is plus, plus, plus 2 times 3. See, I'm moving both hands at the same time. 1 times 1 plus 6 is,
7.
that's what goes,
Can you just do that again?
watch, watch. What spot, if I were to ask you, what spot is this one? It was row 1, column 1, right?
Uh-huh.
Row 1 with my left hand, column 1 with my right hand. This is row 1, column what? Column 2.
1 times 1 is not 7. Wait, but you add it.
One
Plus
more
6
time.
is
1 times 1 is 1. Plus 2 times 3 is 6. 1 plus 6 is,
7.
all right, everybody got that?
2 times 2 times.
Wait a minute.
What do you do for the next?
I know this is the hardest part to agree on. Maybe I needed to write it down to 2 spots.
That's a good idea.
It looks like.
That's a
See.
good idea.
That's what I meant. Shit.
I missed something.
And you just add
What?
Oh, just showing.
I'm showing what I'm adding, and I move both hands every time.
Right.
1 times 1, 1. Plus, I'm moving both at the same time. 2 times 3 is equals 7. Keep row 1, but now start at the top of column 2. Row 1, column 2. 2 times 1 is 2, plus
6, 8.
2 times 4 is 8. 2 plus 8 is 10.
Now you start on row.
Now we're doing row 2, column 1, right?
So you don't use.
Start at the top, start at the left every time.
So you don't use column 2 in the first one ever?
We use column 2 right here.
No, in the first.
In the first set of, in the first
Like in the
matrix.
first.
All right, watch. Row 2, column 1. 3 times 1 is,
3.
move both. 4 times 3 is 15. Row 2, column 2, start at the top, start at the left, 6 plus 16. Row 3, column 1, 5 minus 3.
What?
1 times 5 plus negative 1 times 3, negative 3 is 2.
Like, I was confused why you didn't switch it in half. Because, like, if it's in this one, it's like this row.
I wonder when I paused that because I never started it back.
Did you ever stop my pass, Miss Washington?
No, I did not.
Oh, I probably not. Let's see.
I guess we better do one more multiplication just in case.
Yes. Why did you ask us to get a calculator?
Can we multiply E times C? No?
No.
No, we can't do C by E at all, right? We did E times B.
Can we do A and D?
Oh, they're the same
We did
size,
C
yeah.
times B.
A times D.
A times D, we never did it?
No, you didn't write it down. D is 1, negative 3, negative
Oh, okay.
2, negative 5.
Let's do A times D. A was 1, 2, 3, 4 times D. D was the same size, wasn't it?
Yeah, it's 2 by 2.
Yeah. 1, negative 3, negative 2, negative 5. 2 by 2 times a 2 by 2. Hey guys, interestingly enough, like a 2 by 3 times a 2 by 3 just don't work, right? Even if they're the same size, sometimes they don't work. Squares will always work. Square matrices, 2 by 2, 3 by 3. Yeah.
Well, we have to do
But the
both.
answer, nah. The answer will be a 2 by 2, right? 1 minus 4. We multiply, start at the top with the right hand, move each time. 1 times 1, minus 4, negative 3, minus 10.
Wait.
Start at the far left and the top, negative 3 plus negative 10. Negative 3 plus negative 10. Row 2, column 1, 3 plus negative 8. Row 2, column 2, negative 9 minus 20. Negative 20. All right.
How do you do the first? Is it this
3, it's 1 and 3, and then
Time.
minus 2 and 4.
Oh, why is it not 3 and 8? Wait.
So let's do a couple of these to test. All right. Everybody with me, ready to learn how to throw matrices on our calculators?
I'm always ready to learn.
I'm not.
All right. If you notice, so when we're putting matrices on the calculator, look in the blue writing. What's right above or right below math? Yeah. So if we go second, that X to the negative 1 button,
Wow.
then these little brackets are showing here's matrix A. Well, let's call, well, I guess if we want to do C times D, C times B, let's go down. Oh, I think you got to go over to edit first. Edit matrix C. Enter. And the first thing you do is you tell the calculator what size is matrix C. What is it? 2, arrow right, 3. And what it does is it gives you it gives you all the slots to fill in, right? 1, negative 2, I'm just entering. Negative 4, entering negative 5, enter 6.
Will there ever be a time where, like, for example, the one that we just did, where it's like 1, 2, 3, 4, 1, negative 3, negative 2, negative 5, and then the answer? Will it ever, like, give you the answer and then you have to, like, fill in a blank? Can you do
Probably
that?
not, because there's multiple possibilities.
No. But I quit, and now I'm going to go back to my matrix.
Thank you.
I'm going to go back to my matrix C. I hit enter again. And I always, second mode is a quit. I always go and and do this because invariably I make a silly mistake, put the wrong number. So my matrix C is correct. My matrix B, go back to the matrix, edit, arrow down to B.
3 by 2.
It was a 3 by 2. 1, 2, 3, 4, 5, -1. All right, I think I can see those. 1, 2, 3, 4, 5, -1. I feel good about that one. So I'm just going to quit. And now I can just go, I already have actually matrix C on there, times matrix B. Well, looky there. We got it right. But honestly, by the time you've taken all that time to enter them,
You could have finished this.
you could have finished it.
I could
So,
have finished 2 problems.
exactly.
How do you?
So I don't recommend doing this because you're not going to have it to do on the quiz, okay?
Well, we have to multiply. Can you multiply 30?
3 by 3s?
No, 3 matrices.
I feel like that'd be really difficult.
You would do the first two first and then
The answer to
The
that
next
plus
one.
that
Yeah.
one.
times the other one, yeah.
So just a snowball effect.
Yeah. The homework is on Black. Oh my God.
Hello.
Stop it.